Hi, and welcome back to this series of videos on using a graphics interface controller, which we can see here, to control the operation of a program running in Sonic Pi so that we can start and stop it from playing by clicking on these various buttons over here. And we also seen how we can change the bar at which we're going to start or stop playing by altering these two here. We started by looking at a single version of Frere Jacques, which we went through in some detail, and we developed this into a four-part version. We've got four parts here, which will play together. And we also saw something about the way that this graphics user interface worked by looking at the code which generates this, and on the Sonic Pi side, at some code which is used to receive and decode the OSC sync messages which are sent out every time we press the play or stop buttons here to this. And we've seen that by detecting when one of the two integer variables which are sent by this OSC message is equal to 1, we could start this playing, and when it's equal to -1, we could receive a message which is going to stop the program from playing. The actual way that we did this involved utilizing a command line interpreter, a command line interface for Sonic Pi, which we looked at by means of a terminal program here. And you remember that that had the command Sonic_Pi. And so we've still got it active in this terminal window. If we just go back to the command that we used, which was run file, and then the path name to the file itself. A run file is a built-in command in the latest versions of Sonic Pi, and we're simply sending it from a command line here, so that when we press the return key here, it actually starts that program playing. And if we then change the command to say Sonic Pi stop, we can stop it from playing. And so we then saw that if we put this into a Ruby script, which is up here, Frere Jacques controlled RF auto, it simply is exactly the same thing as we've just been typing in the terminal, except that we've expanded out the full location of where the Sonic_Pi code is stored. There's the command which will stop this program from running, and then the second one, run file, will actually start not this program but the final full version that we're going to use. And so every time this script is run, it stops the program which is in here from running, and it restarts it from the beginning. But of course it doesn't start playing immediately, because the first thing it comes up against is this sync command, where it's going to wait for the play command to be played, clicked on the remote GUI. So that's a brief recap of where we've actually got to, and what we need to do now is to move on to the full program itself, which is in this buffer here. There it is in all its glory. It's quite a long program. In fact, it's so long that it can't play directly. We need to use the run file command, which we see over here, in order to get it going. And so the first time we start it running to be controlled, we'll actually do that in this particular buffer over here, which has just got that single entry in it, and we can control the whole program from there. But we just need to look at the extra bits that we've added from the stage we'd reached, which was to have the full four-part Frere Jacques playing. Now we're going to add some extra code which will let us control the stopping and starting of it. If we start at the top of this, the first thing that's done is that it defines a variable called restart, and all that is the address of where this script is, this Frere Jacques controlled RF auto script in here. So that's what's going to control the stopping and starting. And that is actually going to be brought into play a little further down. We can see some code that we've seen before. Here is the code to wait for the play command, exactly the same as we've got in the previous buffer that we looked at previously there. And underneath it, we have got the code for stopping the program. The only difference is that the stopping section, which is down here, is placed into a thread, and that means that it's not going to sit there and wait for it and hold up the rest of the program, but it's going to be running all the time in parallel, that we're playing the program, waiting for us to press the stop button on the remote control. And when that happens, it will be detected here, and it'll then move on, print on the screen that is stopping the program, and then it's going to run with a system command this restart variable, which is just the command to play this script here. The ampersand at the end just means it doesn't hold up and wait for it to happen. It just goes on as soon as it's issued that command. So that's that section. There's one other important new piece of information right at the start of this program, and that is this variable BPBA. It stands for bars per beats per bar, A for array, and it's simply a list which is going to tell you how many, what the time signature is for each of the sections in this piece. Now in Frere Jacques we don't alter the number of beats per bar, it's in 4/4 time all the way, and so each one of those has the same entry 4, and there's 13 of those entries, one for each of the sections. However, when we first looked at the start video, I did play a piece called Beatus Vir, which had a section in 6/4 time in the middle of it, and so one of these sections in that case would have a value of 6 in there instead of 4. ST is going to be a variable which is used by one of the extra functions we have. There's 3 major functions: numBeats, start details, and get match D, which control the deciding where we're going to start playing in the piece. And that is a variable which is going to hold the 2 pieces of information which are returned by this start details function, and we'll come on to that a bit later on. Those are the 4 pan values that we discussed earlier for the 4 parts which are playing. Now, I said we can't play this because it's too long, so what I've done is to actually put into a later buffer along here just the first part of the program. It's got all the new code, and it's got the information for one part there, but then the program is ended without going on to the other few, because in that way it's short enough for it to actually play in a buffer and we can see what's going to happen. Now, in order to understand how these extra routines work, it's probably easiest to have the music up at the same time, which we can refer to. So let's just get that on the screen again. And also we want to have the controller on the screen again, because we're going to make use of that. What I'm going to do is, first of all, say what would happen if we wanted to start playing at bar number 6 with that note there. Well, what we have to do is we have to set the start variable here to be 6. Oops. Try and hit on it. There we are, 6. And we want to then press the play button. I'll start this program running so that it's now waiting for the play button to be pushed. And I'm then going to click on play. And it does actually start playing. I'm going to stop the program running there because I haven't actually set up the stop button here. I've left the restart thing to point to the final program, and we don't really want to go into that at the moment. But what I do want to do is to bring this across and to look at some of the information that's printed on the screen, because in these functions they've actually put some print statements, or put statements, so that we can see how they work as they actually go through. This isn't normally put on the screen when the program is running. If we look at the very first one of these, which is beats per numBeats, what this is going to do is to work out how many beats there are in any section that we care to specify. And it's easiest to see how this operates by looking at a particular section on here in the notes. Let's take the first section 0, which starts there and finishes there. What this is going to do is, if we feed in to durations there, the variable which holds the durations for the first part, which is B10 down here, that's going to feed in a list with 8 ones in it. And those 8 ones are going to correspond to the 8 crotchets which are in that section. So what this actually does, this numbeats thing, is we start off with a variable L, or length, which we put equal to 0, and then we go round a loop taking each element in this durations, which is B10, in turn, and we add them onto the variable L. So we start there, we're at L0, we read that and say add 1, add another one making 2, another one making 3, 4, 5, 6, 7, 8, and that is going to return the value of L from that function, in other words 8. So there are 8 beats in that first section. If we were to take this section here, this next section, that would give exactly the same value. As we start here, L will be 0, add 1, that's going to make 2. This time we add 2 to it, making 4, then add another one making 5, another one making 6, another 2 making 8. And in fact, all the sections are going to return 8, with the one exception of this double length section in the middle, where we reach the end of the increase in speed and then we're just about to start decreasing again. That's when the fourth part finishes and the first part starts again at the same speed. And this would actually return 4 for that bar, 4 for that one, that's 8, plus another 4, 12, another 8, 16. So that's what numbeats does. Start beats uses an extra piece of information. I'm just going to slide this across a little bit to make it a little wider. And it has 3 pieces of information fed into it. Bn, which is the number, the bar number at which we want to start. B number section start, and that's going to be a list which is set up in a moment, which is going to tell you at which bar each section starts. It's actually going to measure the elapsed section start. So if we look at it up here, what that's going to have put into it, and we'll see how it's done in a moment, is going to be a list, and the first entry is going to be the elapsed bars at the start of section 0, and that's obviously nothing because we haven't played anything yet. At the start of section 1 there, remembering that the numbering starts from 0, we have had 2 bars elapse, and so that would have 2 in it. At the start of this one, it'll have 4 in it, then 6, then 8. It'll go up in 2s apart from the section which is double length, which will add 4 to that. And that is actually not in the same section as defining the 3 functions, but a bit further down, because we actually have to have some data before we can work out what it is. So it's after the definition of the lengths, the durations there. Here it is down here, B number section start, it's a list there. The first value for the first 0 section is 0, and then it simply goes round, and what it does is it works out the number of beats in each section and divides it by the number of beats per bar. Remember that list right up at the beginning there that we made, which has got lots of 4s in it. And so what that's going to do is simply say for the first section we've got 8 beats in it. Divide by 4, that's 2. So the number of elapsed bars at the end of that first section is 2, and that will be stored for the start of the next section. And you can see up here, when I ran this program, I actually got it to print out at the beginning the value of that list. There it is, 0, 2, 4, 6, 8, 10, 12. Then the larger gap going up in 4 bars, 16, 18, 20, right up to the end, and it actually goes just beyond the end of the program. There are 28 bars elapsed when you get to the end of the program, and that is actually printed then as the total number of bars in the piece. So let's come back to the start section, start details here. What this is going to do is when we ask it to start at bar 6, it's going to put a 6 in there. It's going to put this list in here that we've just seen for the second variable, and for the durations it's going to put the entire B list, B1, which contains all the 13 entries. And the first time round start section, the section it thinks it's going to start from is set equal to 0, and we've got 6 bars to process, and it prints that on the screen here. Initial values, start index 0, remaining bars 6. It goes around this loop once, and what it says is the starting bar, the bar you want to start from, bigger than the number of bars in the first section? Well, 6 is bigger than 2, and so it actually subtracts 2 from that, leaving 4 bars remaining, and it then goes on and says, is 4 bars remaining bigger than the start of the next section? And the answer is yes, and so it goes on removing these until the very last time round it says we've got 2 bars left, and there are 2 bars in that section, so that is actually the section we want to start looking at. We're going to start playing from section 2, and you can see that that's actually what we want. There's section 0, section 1, this is section 2. We're going to start calculating where we are in section 2. We actually want to get to there, but we know it's somewhere in this section. And so what that's going to return from us is to say that we want to start in section number 2, and the number of bars we've actually got to look through starting from there is 2. And that's where our final function, getMatchD, comes in. This is going to have fed into it bn, which is going to be 2 bars to process. The number of beats per bar for this section is going to be 4. It gets that by knowing that it's looking up for section 2 how many beats per bar there are. And the durations that we're going to be examining are the durations for section 2 here, which are given in the list here, section B2, this one here. Okay. Now, this is going to print out some details of what actually happens as we go round this particular function. What it's going to do is, first of all, say what's the actual beat that we want to start playing from. Well, so far, remember, we've been looking at elapsed bars. The bar we're feeding in is saying that there's 2 bars to process, but we actually want to start counting from 0 rather than from 1, and so we subtract 1 from that to say actually we want to find the start of bar number 1 into this section, starting reading from 0. And so that's the first thing we do there. We subtract 1 from the bar number, leaving 1, and we multiply it by the number of beats per bar, which is 4, and so we're saying that we actually want to start reading from 0 to get to beat number 4 in this. And to do that, we have 2 other variables here. L is going to have a running length total put in it. X is going to be an index into this list of notes so that we can work out which one we want to start from. It prints the initial values, L0, X is 0. We want to match beat 4 going into this. And so we read the first note, which is equal to a quaver. There it is, that's duration a half. And we make L bigger by that, and we make X bigger, and then we ask the question, have we actually reached beat number 4? The answer is no, we haven't. So we go around and add in the next note, which is another half. X is 2. Have we reached that? No. We keep on going until eventually we get here. L is equal to 4. That's at the 6th note, and that's where we want to be, match beat 4. And so we print out, we return 2 pieces of information, the beat we want to match and the any difference which there might be, which is in fact 0 in this case. If we'd had a tied beat there, that would have given a positive value, and we'll come back to how that's dealt with a bit later on. But that shows you then how we now know where to start playing. We want to start playing from section number 2. We want to start playing at an index of 6 into that list, and we don't need to wait at all before we start playing it. And that is done for all 4 parts so that each part knows where to play and they can all come in synchronized together. So that is quite a long stint. We'll stop there And in the next section, we'll show how this information is applied to the actual playing section at the bottom here, to this little loop down here, which is going to start playing it. You can see that there's one or two slight changes in the loop, and the information before here we have actually already covered, because that is where the start details function was actually called to work out the start section and the number of remaining bars. And this is where we actually worked out which index we are going to start playing from, the 6, and the fact that there wasn't any remaining sleep time to worry about, because we actually coincided exactly with the start of a note at the beginning of the bar. It wasn't a tied note. So next time we will discuss how this loop is put together, and then we can see the whole thing in operation. Thank you for watching.